Hello everyone. Today I'll be presenting my research on how different feature selection methods, entropy and mutual information influence the performance of classification models. And in machine learning we have features, and not all the features are equally useful. Some features can introduce noise or slow down training, and there's where feature selection comes in. It helps to reduce the irrelevant and redundant inputs, and today we will discuss two approaches to solve this, and it's entropy and mutual information. And entropy is an unsupervised method which measures uncertainty, but it's unsupervised, and the mutual information is supervised method that evaluates how feature related to the target value or target value, and that's it. And data-centered pre-processing, we have a balanced dataset which is called airline passenger satisfaction, which consists 24 features, both all the types of features, like numerical, categorical, and ordinal, like numerical, age, flight instance, and etc. Categorical, type of travel, customer type, and etc. And the ordinal ratings, which are also in the string type. They have some rankings, and it's in-flight Wi-Fi service, seat comfort, and etc. And to pre-process this dataset, I used as we use already encoding and scaling, and made it ready for training process. And the dataset is pretty balanced because it has 55% of false. It means dissatisfied, and 45% true, which means satisfied passenger. And feature selection and models, and the feature selection was done based on entropy and mutual information filtering, where we took 60% of all features, and it was calculated by the function that we had in the scikit-learn dot pre-processing, and there we had mutual information and entropy, Shannon entropy calculation, and I made a different data frame for this, for rankings. And as we can see, there is a ranking for mutual information score and entropy score, and it's not the same, as you can see, because mutual information is supervised and entropy is unsupervised. And classification was done on the models like logistic regression, decision tree, and random forest, and the metrics used were accuracy, F1 score, recall, training time. So logistic regression results were like this, where we had all features and entropy based filtered features, and mutual information based filtered features, and the results are as we can see. And so we see that the accuracy, F1, and recall metrics are pretty high for logistic regression, but nevertheless it's not that low it's not that dropped for the mutual information, because it saved its accuracy and the other metrics, while being low on number of features, which pretty much boosted the training time, as we can see, by 3 times, or by 3 times, almost 3 times. And as we can see on the graph, it's a comparison of all features, entropy features, and mutual information features, and entropy features are pretty dropped. Is dropped because it's unsupervised, and it's sometimes cutting off the needed features, valuable features. but mutual information features is not doing the same thing. Uh-huh. Okay, and on the decision tree we had pretty much the same scheme, but we can see that the gap between the metrics is not that high, and it conserved its efficiency while being light on the number of features, and the training time is very it didn't drop that high, but it still dropped to some value, and on the mutual information it's like 0.5 seconds, and here with all features it's like 0.6 0.55 or something, and the entropy is in the middle, like 0.5, and the accuracy is on the mutual information, and the entropy is pretty high, but not that high as all features, but still very respectful value. And the same thing applies to the random forest results, which are pretty high, pretty close, and we did expect this kind of results, because mutual information is pretty supervised and a smart method of pre-processing or feature selection, and entropy is also like this, and on the random forest it did a pretty good job while being not supervised, and it's pretty the same results on the same metrics on accuracy of one score and recall between all features, entropy based features and mutual information features, and it's very good results. And on the training time we can see that it was 0.57 rounded 57, but training time on the entropy features it dropped to the 0.48, almost 49, and on the training time of mutual information features it was 0.4, which is very incredible results, seeing like 60% of features used, and almost the same results on the accuracy of one score and recall, and I think we accomplished our goal on this numerical experiment. And in conclusion, I want to say that feature selection matters. It speeds up training and improves clarity, and as we saw on the random forest, it even conserves the efficiency. It's very efficient as it is with the all features, and entropy, as we saw on the experiments, entropy is very useful but unsupervised. Not very useful, I mean just useful but unsupervised, and the mutual information solves this unsupervisedness of entropy while adding the good results and the good metrics. So yeah, that's it, and we did what we wanted. And for the future work I want to add more metrics for this process of evaluating the results of models and our experiment, and I'm open for your suggestions, and yeah, that's pretty it. Thank you for your attention. Bye.